In the early stages of a project, it is paramount to stay flexible and agile as a design team. And Revit has the right tools for mechanical engineers to conceptualize and analyze mechanical systems flexibly for sustainable space designs at early design stages. And that is our focus in this chapter. In this video, we'll explore the preliminary steps to start a mechanical design project appropriately. This project is a single family residence, but will adapt the HVAC design to a central cooling and heating system, specifically a 4-pipe fan coil system. Hence, the workflow demonstrated throughout the course applies to diverse building varieties. At this point, launch Revit and start a new project with the default mechanical templates, metric or imperial, depending on your region. For this course, we'll go with metric, so I'll click the new projects button here. Then I'll browse to the English folder and choose mechanical default metric. Click open, then OK to start a new project. Next, go to the manage ribbon. From the project location panel, click the location button to launch the location and site dialog. Input your project address. We'll use 120 Arpaio Avenue, Boulder, Colorado 80302 for this course, so I'll type that in and search. On the left here, you will see a list of weather stations and their distances to the address. So we'll pick the first. As you can see, the distance is 0.00 kilometers away. Then I'll click OK to close the dialog. Next, go to the Insert ribbon and click the Link Revit button under the link panel. Then navigate to the Exercise Files Chapter 1 folder and select the architecture model. Set the positioning to Auto Internal Origin to Internal Origin and click Open. Close the following prompt, then select the linked file and launch the Type Properties dialog. Check the room bounding parameter and click OK to close the dialog. Go back to the Manage ribbon and from the Project Location panel here, select the Coordinates drop-down. Use the Acquire Coordinates button to acquire the coordinate system from the linked file. Next, we need to match our levels with that of the architecture model using the Copy Monitor command. So open the default 3D view, then go to the Collaborate ribbon. From the coordinate panel, click the Copy Monitor drop-down. Use the Select Link button to select the linked model. Then from the Tools panel here, click Copy. Check Multiple from the options bar. Then drag over the entire linked model. Use the filter icon on the options bar to filter your selection and select only levels. Then click Finish on the options bar to copy the 4 levels from the architecture model into a project, which is the mechanical project. To complete the copy command, go back to Copy Monitor tab here and click Finish. Next, we need to delete the 2 default levels in the template, and that will also delete the associated floor and ceiling plans. Then after that, we'll create floor and ceiling plans associated with the copied levels. So to do that, go to the View tab, then click the Plan Views drop-down in the Create panel, and then select Floor Plan. From here, select the ground and first floor levels and click OK. Return to the Plan Views drop-down again and select Reflected Ceiling Plan this time. Again, choose the ground and first floor levels, then click OK to create their reflected ceiling plans. You will see the created views on the project browser, so you can see the floor plans here and you can see the ceiling plans here. So to get rid of this question mark, we need to fill in the sub-discipline values or parameter for the reflected ceiling plans. So scroll through the project browser and type in a convenient value for subdiscipline. I can call this multidisciplinary, and I'll remove that question marks. Next, we need to create spaces in the mechanical model. So to do that, go to the ground floor HVAC plan, then go to the Analyze ribbon. Under the Spaces and Zones panel, activate Space. Then set the upper limit to first floor level and the offset to 0. Then click Place Spaces Automatically in the Modify ribbon. That will create 15 spaces automatically. Repeat the process for first floor. This time set the upper limit to roof level. Now we've created 30 spaces in this model automatically. Now we need to use the space naming tool to transfer the space names from the room names in the linked architecture model. So you click on the space naming tool. Make sure the options is names and numbers and the selection is all levels, and that will transfer the room names and number to the spaces. Now click OK. Now on the system browser, we need to inspect the names and delete redundant spaces such as pipe chases. So switch to zones from here, expand this, and make sure you don't have redundant spaces. So you can see some of these are just redundant spaces we have. You can see their locations. So we need to delete that from this project. Finally, we will create the conceptual mass of the building for systems analysis. So go back to the ground floor plan and activate the In Place Mass command under the conceptual mass panel of the Massing and Site ribbon. So click In Place Mass. We'll close this following prompt and I'll name this conveniently. I can call this building mass. Now from the draw panel here, we need to activate the line command and trace over the outline of the ground floor plan to form an enclosed shape. So I'll quickly do that. So switch to the 3D view, select the shape you just created, and then click Create Form from the Contextual Modify panel, and this will create a 3D form from the shape. Then with the Align command on the Modify panel, align the top of the 3D form to the first floor level. Then go back to the first floor and trace around the outline again like we did for ground floor. Again, we'll go back to the 3D view, select the shape and create 3D form. This time we'll type in a value of 4050 into the temporary dimension. Then we will open one of the elevation views, say the west elevation. Then we'll use the reference plane command to draw a 3 degrees sloping plane from the building corner. Again, we'll use the Align tool to align the top of the mass to the reference plane. Then we'll click Finish to complete the building mass. Then we'll go to a 3D view and select the mass and click Mass Floors from the Contextual Modify ribbon. Then we'll select ground and first floor to create their mass floors. So that's it. We've prepared the mechanical model. So we are ready to start conceptual design and analysis for sustainable mechanical systems and space design. So make sure to save this file ahead of the following video.